Okay, so we're going over this test thing. So the graph of the position function x of t equals 2 to the fourth minus 5t squared plus t plus 4 of a particle moving along a line is given. At approximately what times is the particle's velocity equal to 0? So there's no algebra needed here. You're just looking at the graph to determine where velocity is equal to 0. So in earlier sessions, when we were graphing f prime from f, we first looked at where we have max and mins. So that's going to be where velocity equals 0, where we see maxes and mins. So we have this right here. So we have min right there, which is going to be about negative 1.6. So t equals negative 1.6. And then you have this right here, which is about 0.1. And then we have this right here, which is at 1.5. Okay, so where you see max and mins, that's where the velocity is equal to 0. The acceleration is the second derivative to the position function, so you're going to be looking at where it's changing concavity. So where it's changing from concave up to concave down, or concave down to concave up. So we've got concave up, and we're switching to concave down, which looks like it's, I don't know, maybe right there. So we'll put in negative 0.9. Okay, and then here it's switching from, I'm going to say right there, or right here, 0.6, 0.7, 0.8. Okay? So that happens where you see the concavity changing. So that's number one. Next, we're going to find the value of c that satisfies the mean value theorem. The mean value theorem, to satisfy it, it has to be continuous and differentiable over an interval. So a cubic function looks like this type thing. Okay? So it's continuous throughout. There's no jumps, there's no asymptotes, there's no vertical tangents, there's no corners or cusps. So this is going to be continuous and differentiable. So that's why it's going to satisfy this. Now we're going to find a point C where this is going to happen. So this is when you see f prime of C equals f of B minus f of A over B minus A. Okay? So let's find f prime of C first. So you pretty much just do f of C is the cube root of C, which is c to the 1/3. So f prime of C is going to be 1/3 c. 1/3 minus 3/3 is negative 2/3. 1 over c to the 2/3. Okay? And if you want to, you can go in and find f of B and f of A. So this is A equals 0, B equals 1. So f of B, which is f of 1, is the cube root of 1, which is 1. F of A, which is 0, is going to be 0. So you have f prime of C, which is this, 1 over c to the 2/3 equals 1 minus 0 over 1 minus 0. So you get 0. 1 over c to the 2/3 equals 1. Cross multiply, you get 1 equals c to the 2/3. Raise both sides to 3/2. So c equals 1. Okay. A particle is moving along the x-axis with a position function this. Find the velocity and acceleration, then describe the motion of the particle. So the velocity is going to be the derivative of the position function, which is going to be 6t squared minus 28t plus 22. Acceleration is going to be 12t minus 28. Okay? So we found velocity and acceleration. Now we're going to describe the motion of the particle by first starting the position, which is the x-intercept, which is going to be x of 0. is going to be 2, so that's going to be 0 minus 0 plus 0 minus 5. Okay. B, time when the particle is moving left and right. So we're going to be looking at, so this is going to be increasing and decreasing intervals. So we go straight to the velocity. So we set velocity equal to 0. Okay, you could try greatest common factor here, but I'm pretty sure we need to use a quadratic formula. So let's take out a 2. Plus 11. Are there factors of 33 that subtract to get 14? Let's see first. 33, 14. The only one I'm thinking of is 3 and 11. Oh, and we need to add. So factors of 33, we're adding. 3 times 11 is that. You get 3 and 11, so that's good. So you have 3 and 11, which is 1. 0 equals 2 times x plus 1. And then x plus 11 over 3, which is just take the 3x plus 11. Okay. Oh, it's minus. Because it's a negative 14. Okay, so set them equal to 0, 2 equals 0, so that's not going to work. X minus 1 equals 0, and 3x minus 11 equals 0. So x equals 1, and x equals 11 thirds. Increasing, decreasing. Sign chart. 1 and 11 over 3. And here's 0 right here. Okay, so let's pick a number between 0 and 1. That's going to be 0.5. I'm just going to put it right here. So if we do 0.5 minus 1 and 3, so that's going to be 1.5 minus 11. That's going to be a negative times a negative, which is a positive. And then we're going to pick a number between 1 and 11 over 3. Let's just pick 2. So you got 2 minus 1, and then 6 minus 11. That's going to be a negative. Okay, so we have 0 to 1, 1 to 11 over 3, and now we're going to do 11 over 3 to infinity. So, woo! Everything's going crazy! .6. So 11 over 3 is 3.6, so I'm just going to use f prime of 4. So if I put a 4 in here, I got 4 minus 1, which is a positive, 12 minus 11, which is a positive, so that's positive. Okay, so describing my motion along a line. Okay, so my particle starts at -5 meters. Okay? He then moves right and moves, well, never mind, I don't gotta do all that. So let's just look at right and left. So the particle is going to be moving right from 0 to 1 and 11 over 3 to infinity. And it's going to be moving left where it's decreasing, which is going to be 1 to 11 over 3. So we got seconds and seconds. So the particle is going to be beginning at -5 meters, moving to the right until 1 second, moves to the left from here to here, and then moves right here. That's the motion of the particle. Okay, I am not going to have this on the test, so you just need to know what that means. Okay, intervals of increasing and decreasing. So you need to find the derivative for that. So you have f prime of x Just use the power rule. F prime of x. I think I'm going to shrink this one because I'm pretty sure you got to use, well, let's see what we got first. 4x cubed minus 36x squared plus 96x minus 64. I think you can group these, but I'm not sure. I don't think you can. No, I'm going to make this one a little bit more simpler. So we'll just act like this is not here. Okay, so we'll just make it a cubic. So f prime of x is 36x squared plus 96x minus 64. So all of them should have 8 in common, or even 30, yeah. So 36 divided by 8 is 4, never mind. 4, all of them should have 4 in common. Okay, so you got 9x squared plus looks like I could take out more here. Minus 16. No, I guess not. Okay, so I don't know if we can do this. Factors of 54 that I'm going to subtract to get 24. There's not going to be any of those, so you need to use the quadratic formula here. So I'm just going to go back to this one right here. So x equals negative b plus or minus the square root of b squared minus 4ac over 2 times 36. Okay, so we got 96 squared. Well, the square root of 96 squared minus 4 times 36 times negative 64 is 135. So right now, I'm just use decimals here. This will be a little bit easier on the test. So I got negative 96 plus 135.764502 divided by 72. So I get x equals 0.55 and x equals negative 96 minus 135.764502 divided by 72 is negative 3.218. Increasing and decreasing, use the sign chart. Okay. So over interval 0 to 5. So negative 3.218 we do not have to worry about because we're only looking from 0 to 5. Okay, so f of 0.5, so f prime of 0.5, let's see if that's going to be a negative or a positive. You can put that graph into the equation, just do trace here. I'm just putting in the derivative function. Again, this problem will be easier on the test. So that's what the derivative looks like. I'm just putting in 0.5. It's a negative. So it's negative here. And then if I put in a 1 here, it's going to be positive. Okay. So you're looking at what y is doing. Y is positive. Okay. Extrema, you do have extrema, so you're going decreasing to increasing. And you're also going to have a max here and a min here. You got to look at your endpoints too. So now you check those. So you're going to check f of 0. So just f of 0. F of 0 is going to be 0 because everything stops with the x. F of 0.55228 is gotta put the other one in my calculator. 12x up 3 plus 48x squared. That's 64x. Okay, 0.5528 is negative 18. And f of 5 is 2380. Okay, so that's going to be an absolute max here. Lowest point is going to be that, so that's going to be the absolute min. This is going to be a local max because it's going from, so it's decreasing, so it's coming from somewhere, so it's going to be a little higher than the rest. So that's a local max. And that's also a local min. And that's a local max as well. Okay, concavity intervals, you get the second derivative. So 36 times 2 is 72. I'm just going to start that up here. F double prime of x is 72x plus 96. Set that equal to 0. Negative 96 divided by 72. So subtract 96 on both sides because you got to set that equal to 0. Divide by 72, you get x equals negative 1.33 repeating. Sign chart that. And we can't tell because it's not an interval, so you don't even have to look at that. Okay? But you do need to check your concavity intervals from 0 to 5. Okay, so just do f double prime of 1, and that's going to be a positive. So it's going to be concave up from 0 to 5. No POI over interval. But if there was, you would check the original function back in here. And it's concave up from 0 to 5. So if I were to draw this, I got 0, 0 here. I got 0.5, negative 18, which is way down there, so I can't even graph this. But the graph looks like this. So that's not even in your domain. But if I was, let's just pretend this is negative 18 down here. So we got that, negative 18, 0.55, and 5, 280 something. So it would look like this. That's what it looked like. So it's concave up. You got a local max. And there you go. Okay, so let's sketch a continuous curve given the following. So just take this one step at a time. Do the defined points first. So you have 2, 1, 4, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. It's falling in concave up from x is less than 2. So falling means it's decreasing. There's a horizontal tangent there too, but we just don't know if it's going to be facing down or up. But since it's falling and concave up, it's going to probably look like this. So it's falling and concave up. Rising and concave up from 2 to 4. So it's rising, so it's increasing, 2 to 4. 4 is an inflection point, so that's going to be from where it's changing from concave up to concave down. So it's rising and concave down. And there's a horizontal tangent at 6, 7. And it's falling and concave down. And there's your graph. That is your test review. If you have any questions, let me know. Bye-bye.